When an Air Canada customer service chatbot hallucinated a bereavement discount for a grieving passenger, the airline refused to honor the promised rate. In court, the airline attempted a novel defense. They argued the chatbot was a separate legal entity responsible for its own actions, attempting to distance the corporation from the algorithm. The tribunal rejected that argument outright. They ruled the airline holds strict accountability for all information presented on its website, establishing the legal precedent that the deploying enterprise holds the ultimate liability. We see the same strict accountability applied in Australia, where the Consumer Commission took the travel website Trivago to court over deceptive hotel pricing. A judge ordered a landmark audit of Trivago's machine learning algorithms. The audit proved the system favored higher commission hotels, resulting in millions in penalties. Reputational damage moves even faster than legal action. McDonald's recently attempted to automate hundreds of its drive-thrus using AI voice recognition. Customers realized the system was hallucinating, randomly adding hundreds of chicken nuggets to orders or dumping 9 scoops of butter onto a single ice cream. The company had to rapidly pull the initiative offline. These cases prove that AI governance is no longer a back-end technical issue. It is a core business liability, where the enterprise holds absolute legal and financial accountability for the actions of its autonomous systems. To manage software risk, traditional cybersecurity relies on a concept called shifting left. Shifting left is the practice of integrating security testing and controls into the earliest stages of the software development lifecycle. A dangerous misconception has emerged in the industry that applying this standard practice is enough to secure an artificial intelligence model. On the left, a linear CI/CD pipeline delivers traditional code. Standard security gates here function normally, catching bugs before deployment. On the right, the complex machine learning pipeline is cyclical. Raw data and training weights operate differently, entirely bypassing those linear gates. This opens the door to novel risk vectors specific to machine learning, like data poisoning, where malicious actors intentionally corrupt the training data to manipulate the model's future behavior. It also introduces the risk of inherent systemic bias, where the model learns and scales human prejudices present within its foundational datasets. When compliance teams try to apply traditional IT security checkboxes to these nonlinear machine learning vectors, they create what auditors call unauditable controls. These unauditable controls lead to a check-the-box compliance exercise. The company claims to have security in place, but cannot actually demonstrate it, providing zero actual protection in court. Treating artificial intelligence like standard code creates a false sense of security. Mitigating machine learning risk requires abandoning the old playbook and constructing an entirely new, specialized 5-pillar architecture. The first pillar of this architecture is a comprehensive AI asset inventory. In security, you cannot protect what you cannot see, and the models are the crown jewels. This foundation acts as a dynamic repository, actively tracking every machine learning asset inside the organization. Before any engineering begins, developers are mandated to register every new model they intend to build or deploy into this centralized system. The system captures critical metadata: the specific purpose of the model, the intended end users, the global jurisdictions it will operate in, and the exact underlying data sources feeding it. This gives GRC teams a single pane of glass to uniformly apply policies. GRC stands for Governance, Risk, and Compliance, which is the organizational strategy for managing enterprise risk and meeting legal requirements. Sitting directly on top of the inventory is the second pillar, dual-layer risk assessment, splitting threat evaluation into macro and micro halves. The macro level focuses on organizational readiness. This assessment forces the C-suite to evaluate the company's overall technology readiness, the availability of specialized internal skill sets, and their exact threshold for absorbing new legal liabilities. The micro level operates much closer to the code. This tactical assessment evaluates specific end-user impacts, measuring safety, transparency, and alignment with NIST AI principles. NIST is the National Institute of Standards and Technology, a U.S. federal agency that develops widely adopted cybersecurity frameworks. Without a centralized inventory and contextual risk mapping, corporate leadership is flying blind into an entirely new threat landscape. The stack then grows to its third pillar, data governance. While standard software data governance focuses heavily on accuracy and privacy, AI data governance requires an entirely different focal point. The highest priority control for evaluating training sets is data diversity. Failing to build a diverse and inclusive dataset mathematically guarantees a flawed outcome. The algorithm will filter out nuance, resulting in highly biased outputs that discriminate against large portions of your user base. Once trained on diverse data, the system moves to the fourth pillar, model verification and validation. Traditional functional regression testing checks if software produces the exact same predictable output every time. This is useless for evaluating non-deterministic AI models. The required replacement methodology is adversarial AI testing. Here, engineers actively try to confuse the model by bombarding it with hostile, contradictory, and edge case inputs. The goal is not to prove the system works. The goal is to intentionally map the exact boundaries of where the system breaks down. Teams must define strict threshold metrics during this phase, such as establishing an acceptable hallucination rate that the model must stay below before production is approved. Trusting an AI model's default output without this rigorous pressure testing is a massive liability. Models must be intentionally attacked and broken in a sandbox before they can be deployed. The final layer locks into place at the top of the stack: continuous observability. Once an AI system is deployed into production, traditional cybersecurity risks and the model's own behavioral errors become deeply intertwined. Standard SIEM and log monitoring tools are entirely blind to these hybrid issues. SIEM stands for Security Information and Event Management, which is traditional software used to aggregate and analyze standard IT network alerts. To capture these unique metrics, organizations must deploy specialized AI observability tools. The first critical metric these tools track is performance drift. As an AI model interacts with live data over time, its accuracy and reliability can degrade, drifting wildly off its original baseline. The second metric is the continuous monitoring for the gradual introduction or amplification of bias as the model processing new user inputs. The third critical metric is maintaining system explainability, ensuring that auditors can always trace exactly how the model arrived at a specific autonomous decision. Organizations must configure automated alerts so that engineering and security teams are immediately pinged the moment any of these specific thresholds are breached. An AI model's safety is not a static state. Without continuous observability, a model that is perfectly safe at launch can silently degrade into a corporate liability. This technical architecture will fail completely without absolute top-down leadership support. The Executive Steering Committee must act as the lead commissioner. They don't play the game directly, but they set the rules and define the non-negotiable boundaries for the engineers. Reviewing AI use cases, residual risks, and system metrics must become a mandatory standing agenda item in all critical leadership meetings and corporate town halls. This top-down mandate is being strictly enforced by the massive, overwhelming wave of global regulations arriving right now. This map shows the overwhelming scale of active AI legislation worldwide. Different jurisdictions are rapidly passing highly specific laws detailing exactly how artificial intelligence can be developed and deployed. Looking at the entire map, it is clear that the window for reactive compliance has already closed. Companies operating across these global borders must have this exact 5-pillar framework active today to legally do business. AI governance can no longer be treated as an afterthought or a reactive patch. It must be engineered directly into the core operational DNA of the enterprise, allowing the organization to balance aggressive innovation with ultimate survival.